Hello, beautiful people, and welcome. In this video, we are continuing our discussion about trig identities and how to apply these trig identities to simplify trig expressions. Now, we're also going to be verifying identities in this video. So let's start off with some basic fractions. Let's say we have 2/3 plus 1/4. Now, when we are adding fractions, we need to have common denominators. So what I'm going to have to do is I'm going to have to multiply 2/3 and 1/4 by something that will give us the same denominator. So 2/3 will be multiplied by 4. 1/4 will be multiplied by 3. So that gives us 8/12 plus 3/12. And then that means that I can continue solving with the same denominator. 8, 9, 10, 11. And we get 11/12 as our answer. So this method of adding fractions is exactly the same when adding fractions with trig functions. So let's say we have 1 over cosine plus 1 over sine. These are two fractions without a common denominator. So what I'm going to do is I'm going to have 1 over cosine plus 1 over sine, and I need to create a common denominator. So I'm going to multiply cosine by sine, top and bottom, and for sine, I'm going to multiply cosine, top and bottom. Now this is sine of theta, cosine of theta. I tend to not say the theta part. So then we have sine of theta over cosine of theta times sine of theta plus cosine of theta over sine of theta times cosine of theta. Now because they have common denominators, just like here, we get to add the numerator, keeping the denominator the same. So that means I have sine of theta plus cosine of theta all over sine of theta cosine of theta. Now this example is just showing you how to add fractions together. So we're going to leave it like that for our answer. Let's go ahead and try another one. So let's say we have a binomial in the denominator. It works the same way. We want to get common denominators. So I have 1 over 1 minus cosine of theta and 1 over 1 plus cosine of theta. So common denominators. I'm going to put parentheses around the binomial. Very important you do that. And we're going to multiply top and bottom by the other's denominator. So I'm going to multiply 1 plus cosine of theta on top, 1 plus cosine of theta on the bottom. Same thing here. 1 minus, because we have a minus in the other denominator, cosine of theta on top, 1 minus cosine of theta on the bottom. Now notice I am taking the plus from the right fraction and I'm taking the minus from the left fraction. Also notice that I am doing parentheses. That's very important. Let's go ahead and multiply out. So notice we have a binomial times a binomial. Per our last video, you can use patterns if you'd like, or you can distribute. I will be using patterns. So in our numerator, here, we have 1 plus cosine of theta. That comes from here over, and here's where we use our pattern. We have the difference of squares. So that means a squared minus b squared. A is 1, a squared is 1. Then we have minus cosine squared of theta. So this comes from here. I am adding because we have addition. And once again, we're going to multiply with just 1 minus cosine of theta times 1. And then for the denominator, we get to use the pattern. a squared. So 1 squared minus cosine times cosine is cosine squared of theta. Now again, this pattern only works if we have the difference. So one of them has to be positive, the other one has to be negative. If they're both positive or both negative, this does not work. Now that we have common denominators, we can continue combining. We have 1 plus cosine of theta plus 1 minus cosine of theta all over 1 minus cosine squared of theta. We do not combine these. This is just one common denominator. I see a cosine here that's positive. I see a cosine here that's negative. That's just adding and subtracting. So those go away. I'm left with 2 in the numerator. 1 plus 1 is 2. Now in the denominator, we're still left with 1 minus cosine squared of theta. That still is happening. And then we go back to our cheat sheet from our previous video for our identities. Now I see a cosine squared. I'm thinking perhaps that is an identity. We're going to have to check. 1 minus cosine squared is indeed an identity to sine squared of theta. So we're going to rewrite this as sine squared of theta. And then we still have that 2 in the numerator. Now you can split this up and say I have 2 times 1 over sine squared of theta to simplify it even further, because I know that the reciprocal of sine is cosecant. So if we look here, cosecant is equal to 1 over sine. Now I do have a sine squared, which is, it's okay, it's not the end of the world. So that we have 2 times, the reciprocal of sine is cosecant. Now I do have sine squared, so this ends up being cosecant squared for my answer. So 2 times cosecant squared of theta is my answer. Let's do some more. Again, reminder on your step number 1 is to rewrite everything in terms of sine and cosine. If you have something squared, try to rewrite it as a different identity, like a reciprocal identity or a tangent-cotangent identity. Then see if it's a Pythagorean identity. So step number 1, rewriting terms sine and cosine. So tangent is sine over cosine minus, so we have a minus here. Then we have secant. Secant, if we look at our cheat sheet, is 1 over cosine. Oops, there it is. Secant is 1 over cosine. So we can do that. 1 over cosine of theta. Now it is squared, so don't forget to put that 2 on cosine, divided by tangent, which is sine theta over cosine of theta. So a lot is happening here. So notice this is now a combination problem. We have a fraction divided by a fraction. So here we're going to keep, change, flip. Now you do have a choice to make here. You can take this to minus this technically negative, place it on your numerator and make it addition. Or you can leave it there and do that after. It is your choice. Just don't forget that it's a minus, not addition. So we have, this is a thinking bubble. We're kind of doing this off to the side. 1 over cosine squared of theta. Keep, change, flip. So you have cosine of theta over sine of theta. So I'm going to split this up a little bit further. Because I have a cosine squared of theta, that is cosine times cosine. So when we are multiplying by cosine over sine, we actually can simplify one of the cosine with one of the cosines. So we will have a 1 here, a 1 here. So we end up having 1 over cosine of theta times sine of theta that we're going to bring back here. So again, what do we have? Let's bring this down. We have sine of theta over cosine of theta minus, don't forget that minus, and now we are changing this to 1 over cosine of theta times sine of theta. Now we still have fractions that we are subtracting, okay? So at this point, I am going to change this to addition, placing that a minus on my 1. We do need common denominators. So common denominator here, I have a cosine and sine. I just have a cosine, so I'm going to be multiplying both sides by sine of theta, top and bottom. So what do we have? We have sine squared of theta plus a negative 1, so minus 1 in the numerator, over common denominator now, sine of theta, cosine of theta. So this numerator became this numerator. So you guys know where it came from. And then the common denominator is here. Now I see a squared and I see a 1. That's a binomial. To me, that's screaming Pythagorean identity. So let's check. We have a sine squared of theta minus 1, sine squared of theta minus 1. I have a 1 minus sine squared of theta, but let's see if we can manipulate it into being something like this. So if I have sine squared of theta plus cosine squared of theta equals 1, let's rewrite this. You can do this off the side of a sheet of paper. I'm obviously doing it on my Pythagorean identity sheet. And what do we want? We want sine squared minus 1. So if I subtract 1 both sides, I get sine squared of theta minus 1 plus cosine squared of theta equals 0. So I get my sine squared of theta minus 1, but I need to get rid of this cosine now. So sine squared of theta minus 1 is equal to, I'm going to subtract cosine squared of theta both sides. So I get negative cosine squared of theta as my answer for sine squared of theta minus 1. So it ends up that, yes, we can manipulate it to work. That doesn't always happen, so be careful and double check. So sine squared of theta minus 1 is equal to a negative cosine squared of theta. So this one here can be negative cosine squared of theta over sine of theta cosine of theta. Just like we did here, we are going to rewrite cosine squared of theta as cosine times cosine. And you can rewrite this negative 1 as negative 1 times, so it doesn't confuse you as to if the cosine's negative or not. It's just a multiplier of negative 1. Next, we have sine of theta times cosine of theta. And now you can see that these two can be divided out, and you're left with negative 1 times cosine of theta over sine of theta. Now, don't worry about that negative 1. It will stay, but what about cosine over sine? Now we know tangent is sine over cosine, so it looks like the fraction has been flipped, or it's the reciprocal of the fraction. So that means we are taking the reciprocal of tangent, which is cotangent. We're left with negative 1 times cotangent of theta, or you can just write it as negative cotangent of theta for your answer. Okay, let's move on here. Now I did my 1 on this example very extra because I wanted you to see that it's one whole thing, right? I could have wrote a 1 that's very small, but I wanted to be a little extra here. Step number 1, rewrite things in terms of sine and cosine. Sure, let's do that. However, for this example, I actually recommend doing common denominators first before you throw in fractions. I know tangent is going to be sine over cosine. I know cotangent is the reciprocal of that, which is cosine over sine. But that means I have a fraction over a fraction, which means keep, change, flip, and hopefully I lost you because I lost myself, right? So let's do common denominators before we do anything with fractions. I'm going to rewrite this as tangent of theta over cotangent. Now, because I have 1, I'm going to rewrite 1 as cotangent of theta over cotangent of theta. Now, why am I doing this? Because cotangent divided by cotangent is 1. It's the same thing on top and the bottom. So this 1 becomes this 1. Both are just 1. Now that we have common denominators, we can proceed to add, not multiply, we're adding tangent of theta plus cotangent of theta over cotangent of theta, just cotangent of theta. There was a second, I hesitated, I was going to add, but it's like, wait, common denominators, there's only one denominator. Don't add the denominators. Okay, so we have, and I'm thinking maybe I complicated my life here. Oh, let's just keep going. Perhaps the other way would have been better. Perhaps. Live and learn, right? All right, so tangent is sine of theta over cosine of theta plus cotangent is cosine of theta over sine of theta all over cotangent, which is cosine of theta over sine of theta. Resist the urge to cross these out. You may not cross those out because addition and division do not undo each other. Okay, so that means we do still need common denominators. I was hopeful that we didn't need them, but yes, we do. So we're going to multiply this by sine. We're going to multiply this by cosine. So I'm working with the numerator only. So in the numerator, we have sine of theta squared, sine squared of theta, sine times sine, over cosine of theta times sine of theta, plus cosine times cosine is cosine squared of theta, over sine of theta, cosine of theta. Now I did rearrange these, but these are exactly the same. All over cosine of theta over sine of theta. Let's combine. So sine squared of theta plus cosine squared of theta should be screaming identity right now. And I'm just going to write this as sine of theta, cosine of theta. Again, denominators are the same. Over cosine of theta, sine of theta. This right here should be screaming identity to you. We go back to our identities. It's one of our main ones. Sine squared plus cosine squared equals 1. A squared plus b squared equals c squared. So we have 1 over sine of theta, cosine of theta, all over cosine of theta, sine of theta. Again, we have a fraction over a fraction. This is your keep, change, flip. So I'm going to keep 1 over sine cosine times flipping the fraction, sine of theta over cosine of theta. Yes, you can divide because we have multiplication and division. So we're left with 1 over cosine of theta times cosine of theta, which we can just write as cosine squared of theta. But since cosine squared of theta is in the denominator, that means it's a reciprocal of something. Cosine has a relationship with secant. And since this has been flipped, or a reciprocal has been done, we're going to use the reciprocal identity to say this is secant. It is squared, so we're going to say secant squared of theta. If you tried it the other way and simplified this first, I'm curious to see if that was quicker for you, if you got to the answer before we did. All right, let's go ahead and do the next one. Again, fractions, common denominators. I do believe we did this one already as our first example. And I am correct. So we're going to skip. We're going to see example, I think it was example 1 or 2. We already did this one. Let's move on. Okay, so this one wants us to verify an identity. So remember, verifying an identity will be choosing one side and you're going to make it equal to the other side. Now, typically there's going to be a clear winner, which one has more things for you to work with. And if you have more things to work with, that's the side that you want to choose because things can simplify, things can cancel out, things can go your way. So I'm going to choose the one that has a big old fraction to it. Now I do see a pattern that we're going to have to factor. So it comes from the previous video that we done on how to factor. If you want to substitute x to be sine of theta for that one, you end up having, you don't have to do this. This is like in a separate thinking bubble. I'm just showing you how to factor this. This ends up being x squared minus 2x plus 1. This is guess and check. So x minus 1, x minus 1 is what you end up having. Or that means you have x minus 1 squared. But since x is sine, what ends up happening when you factor is you get sine of theta minus 1 and sine of theta minus 1. After you factor, let's write down the denominator. You see that this question happens very quickly. This verifying the identity happens very quickly because we have multiplication and we have a binomial that's exactly the same. In our class, we say the bubbles are matching. If the bubbles match, then you can divide. So since our bubbles are matching, we can divide sine of theta minus 1, sine of theta minus 1. That gives us sine of theta minus 1. And let's bring down our original. And notice that they equal each other, so the identity has been verified. Okay, let's move on. All right, let's rewrite in terms of sine and cosine. Tangent, hopefully this should be a little bit easier now. Tangent is sine of x over cosine of x. Secant is the reciprocal of cosine, so 1 over cosine of x. This is where we have our keep, change, flip. We're going to keep our sine of x over cosine of x. We're going to change this to multiplication, and we're going to flip the cosine of x over 1. Now we get to divide. Cosine divided by cosine is 1. So we have our answer is sine of x over 1, or just sine of x. Next, let's go ahead and factor. We do have a common factor here. I see a cosine. I see a cosine. So that means I'm going to remove a cosine, or you can say divide by cosine of x. That means our GCF, greatest common factor, is cosine of x. Remove it. Left over, cosine divided by cosine is 1. Cosine divided by cosine is 1. Left over is sine squared of x. And again, it should be screaming identity to you, specifically a Pythagorean identity. Let's check. 1 minus sine squared of x. 1 minus sine squared of x is cosine squared of x. So we get to change this to cosine squared of x. Oh, x, not theta. Times cosine of x. So that means we just have 3 of them. So cosine cubed of x is your answer. Next up, we have common denominators. So we're going to rewrite this in terms of sine and cosine. So we have sine, cosine, but we do have cotangent. So since we have cotangent, cotangent is the reciprocal of tangent. Tangent is sine over cosine, so we have cosine over sine. Now here, This right here is just multiplication. So multiplying, we just put a 1 underneath and we multiply across, not a big deal. We end up having cosine squared of x over sine of x. Now it's the other stuff that we have to worry about because we are adding. I have to put a 1 underneath and get common denominators. Since I have a sign on my right fraction, nothing except 1 on the left fraction, we're going to multiply top and bottom by sine of x. We end up with sine squared of x over sine of x plus cosine squared of x over sine of x. Adding that together, we end up with sine squared of x plus cosine squared of x all over sine of x. And again, should be screaming at you now. Identity, identity, identity. This is our major identity. Sine squared of theta. Oop, not that one, this one. Sine squared of theta plus cosine squared of theta equals 1. So that means this right here is just 1. Let's see if I can fit it in. 1 over sine of x. And again, since sine is in the denominator, meaning it is a reciprocal of something, so sine has a relationship with cosecant, and our answer is cosecant of x. Okay, now this is a new one for us, splitting into two fractions. We have not seen this yet. So let's say we have something that is a binomial in the numerator and not a binomial in the denominator. We can separate this out into two fractions, giving each section the same denominator. It's kind of like undoing the addition subtraction that has been done when they combined the numerator. So we have secant of x over secant of x minus cosine of x over secant of x. Now secant over secant, we know this is just 1. So we have 1 minus cosine is just cosine of x. Secant has a relationship with cosine, so we have 1 over cosine. Once again, we have our keep, change, flip. So we end up having 1 minus, I'm going to put this in a bracket because we're doing this off kind of its own little thing, cosine of x times cosine of x over 1, keep, change, flip. So we have 1 minus cosine squared of x. That's where that came from. And again, it should be screaming, identity, identity, identity. 1 minus cosine squared of x. Let's see which one it is. 1 minus cosine squared of x is sine squared of x, or theta. Okay, let's get going. And that is it. All right, beautiful people, thank you so much for watching. I'll see you in the next one.